Hi everyone, today we're going to take a look at week 9, lesson 1. Week 9, lesson 1 is asking us to simplify radicals. On this assignment, we are just continuing the exact same skill we started in week 8, lesson 2. And so in some ways there's no new material. If you practice the IXLs, it is the exact same IXL link as week 8, lesson 2. There is a new worksheet for it. It's simplifying radicals number 2, but it is the exact same skill that was practiced in the worksheet for week 8, lesson 2. And so for this lesson, I am going to refer back to the material that we covered in week 8, lesson 2, where we gave an example problem and then we talked about the steps. So I want to start by highlighting these step-by-step notes that we took week 8, lesson 2, where we decided that the first step is that you need to identify the largest perfect square that radical is divisible by. Meaning, if you took the radical that the equation gave us and then used your perfect squares and divided it by that it's a nice whole number. So you want to figure out what is the largest perfect square that radical is divisible by. That is our first step. Our second step is going to be to write out those factors underneath a radical sign to create an equivalent expression. Our third step would be to separate all of those numbers underneath their own radicals. And then our fourth step would be to solve the perfect squares that are there. And then our final step, step 5, would be to rewrite your final answers. So those are the 5 steps that we're going to use every time we are simplifying these radicals. So now I'm going to go ahead and jump back to our page for this week, week 9, lesson 1. And I want to go over a couple of the problems. I'm going to start with number 1. Problem number 1 on the worksheet says the square root of 80. So I know from my steps that the first thing I want to do is identify the largest perfect square that 80 is divisible by. So we're going to take a look at the list of perfect squares here. We know that 81 is larger, it's 9, so that doesn't work. If I take 80 and I divide it by 64, so I type in 80 divided by 64, it's going to give me a decimal value, and so that one doesn't work. Then I take 80 divide by 49. When I type that in my calculator, I'm also going to have a decimal value. So 80 is not divisible by 49. Then in my calculator, I'll type in 80 divided by 36. That is also going to give a decimal value. It is not a whole number, it does not work. So I'll type in 80 divided by 25. It's going to be a decimal value, not a whole number, so it does not work. And now let's try 16. On my calculator, I have 80 and I divide by 16. Oh, hold on. 80 divided by 16. I get the answer 5. I have a different setting on my calculator, so it kind of looks like 500, but that is 5.00. So 80 divided by 16 is 5. Because it's a whole number, I now know that 16 is the largest perfect square that 80 is divisible by. So my second step is to write all of that out underneath the radical. So I know that the square root of 80 is exactly equal to the square root of 16 times 5. And those are equivalent expressions. Then I can rewrite all of those terms underneath their own separate radical. So the square root of 16 times 5 is exactly equal to the square root of 16 times the square root of 5. And then we can follow my next step, which is to solve the perfect squares that are written. Well, my perfect square here is 16. And we know from our list of perfect squares that the square root of 16 is 4. So the square root of 16 is 4. Now we can ask ourselves, is the square root of 5 divisible by any perfect squares? If we follow the same process, we would see that the only numbers smaller than 5 are 4. 5 divided by 4 would give us a decimal value. And then everything's divisible by 1, so dividing something by 1 does not help us simplify anything, so we don't include it. And that is how we know that the square root of 5 cannot be reduced any further, so we rewrite it. And we would read this expression as 4 root 5. We can always verify and double check our answers by using the calculator. I can type in the square root of 80, which is 8.94. And then I can also check our answer. So I can do the square root of 5 times 4, which is also 8.94. The fact that those answers on the calculator match lets me know that I did this math correctly. So let's do another example. Let's look at number 2. Number 2 says, simplify the square root of 50. Our first step is to identify a perfect square that it is divisible by. Well, we've got the square root of 50. 49 is divisible by 50, but 50 divided by 49 is going to give us a decimal, not a whole number, so it's not divisible by that. I can do 50 divided by 36. It will also give me a decimal value, so it does not work. And then I can do 50 divided by 25. Well, if I do 50 divided by 25, my answer is going to be 2. And so because it's a whole number, I know that 50 is divisible by 25. So my next step is to write all of that out. The square root of 50 is exactly equal to the square root of 25 times 2. And then my next step is to put all of these underneath their own radicals. So the square root of 25 times 2 is exactly equivalent to the square root of 25 times the square root of 2. And now, my next step is to solve my perfect squares that exist. 25 is a perfect square. What is the square root of 25? It is 5. And now I can look at that root 2 and decide, is it divisible by a perfect square other than 1? And we can see that other than 1, there's no perfect square that 2 would be divisible by, because our next one is 4, and 4 is already much larger than 2. So it cannot be simplified, and therefore we rewrite it. And we can see that our answer to number 2 would be 5 root 2. When you get down to numbers 16 through 20, you can see some that get a little bit more challenging. So I want to discuss how we solve for these. We're going to start with number 16, because that will be probably a challenging one for some of us. On your worksheet, number 16 says simplify 3 root 16. Well, now we have a whole number in front of our radical sign. And so far when we've simplified, we've always had a whole number in front of the radical. But just because there's a whole number does not mean that what's inside the radical is in its most simplified form. So what I want to take a look at is specifically the 16. How can we reduce the square root of 16? Well, we need to figure out what is the largest perfect square that 16 is divisible by. Well, when we take a look at our list of perfect squares and we decide where does 16 fall on this number line, we can see that actually 16 is a perfect square. And when you take the square root of 16, you get the answer 4. So I know that the square root of 16 is 4. But I can't forget about this 3 that was up here first. That has to come down. And now if I don't put it in operation, it almost looks like I wrote the number 34, which is not what I want. When we have the square root of 16, or the square root of 80, or the square root of 50, or any of these radicals, we can almost think about it like a variable when we were talking about variable equations. We're very used to, in math, seeing things like 3x and knowing that the variable x stands for some unknown amount or some unknown number. And we've talked a lot when we were solving equations that when you have a number right before a variable, that this is 3x, but it's technically 3 times x. And so when you have a number right in front of a radical, it acts the same way. This is 3 square root 16, or 3 root 16, but there's technically a multiplication sign right there. So when we simplify, the square root of 16 is 4, it's not 34, it is 3 times 4. And then we can use our calculator to just reduce that all the way. Well, what is 3 times 4? It gives us the answer, 12. Let's take a look at another one of these so we know if we have the hang of it. Number 17 on week 9, lesson 1. Number 17 says 5 root 8. What I care most about right now is this radical 8. And is it divisible by a perfect square? Well, the only perfect squares that are smaller than 8 are 1 and 4. And as we said multiple times now, dividing anything by 1 isn't going to change the number, so it doesn't help us simplify. So therefore, we do not include it. So the only thing we have to think about is 8 divisible by 4? Well, if you take 8 and divide by 4, you get 2. Verify that on a calculator. 8 divided by 2 gives you 4. So I'm going to solve this the same way. I'm going to bring down this 5. And I'm going to go ahead and write a multiplication sign there, just so I don't forget that I am ultimately multiplying. But now I have, instead of the square root of 8, I have the square root of 4 times 2. And then I'm going to rewrite this expression again. 5 is just going to carry down because it's a whole number outside the radical. The square root of 4 times 2 can still be written as the square root of 4 times the square root of 2. Now I need to work with my perfect squares. Well, the square root of 4 is a perfect square. The square root of 4 is 2. Because it's a perfect square, it comes outside of that radical sign. I'm still going to carry down this 5, and I'm still going to carry down this root 2. So I now have 5 times 2 times root 2. Now I have two numbers that are outside the radical. I'm going to combine those. 5 times 2 is 10. So I could write it as 10 times root 2 once I bring that down. It's just a little more accurate. We don't need to include that multiplication sign. It is implied, just like it's implied when it's a number in front of a variable. So our final answer is 10 root 2.